Hey everyone, thanks for joining. It's the November conference call for 2025. Obviously, there's a lot of research progress to go over and a lot of updates to share with everyone. So, Enzo would like to go over some research updates and kind of describe our transition from Italy over to Slovakia. And then we did also put together a PowerPoint, so we'll go through that. And then after we get through these things, we'll open the floor for questions as we usually do. And we'll just go ahead and raise your hand at that point, and we'll invite you onto the stage and answer your questions. So without any further ado, Enzo, the floor is yours, and go ahead.
Thank you, Ryan, for this brief introduction. I want to say hello, first of all, to all the donors, to all the supporters. And I want just to summarize what we did so far. I remember in my memories that I started to consider in 2010 different technologies to regrow the human foreskins. But, having considered all of them, I have thought that the best way to, let's say, have the real foreskin back, the one like nature intended, was to use foreskins coming from adult cadavers. And it chose the technology that was called at that time, and even today, obviously, decellularization. So my original idea, I started thinking to use the ECM of those foreskins to repopulate it with the recipient cells and transplant those foreskins in vivo to our patients. So this was the original idea. In the following years, we have simply pursued this strategy. Of course, first of all, we had to verify the goodness of the decellularized technique, and we had to understand if it worked. So we did this strategic partnership with the Banca della Cute in Cesena, Italy, and their main scientist, Dottoressa Elena Bondioli. And we did in 2014 this preliminary study. It was a preliminary data for the development of a decellularized membrane from animal dermis. Basically, we used 8 bulls foreskins and we decellularized them with 4 different protocols. All of these decellularization methods tested in our study were able to create the animal dermis, displaying a drastic reduction of cell viability whilst maintaining a normal tissue morphology and structure. So the experiment was successful. And, I consider this the first concrete milestone of our research. Then, the following year, in 2015, we started to work on the following research that then we published in 2018. The development of a decellularized extracellular matrix based the biomaterial scaffold derived from human foreskin for the purpose of foreskin reconstruction in circumcised males. So we did decellularization of 15 adult foreskins, and the results found foreskin dermal matrices were without viable cells, and the matrix of foreskin dermal matrices was maintained. And I particularly have a good memory of this experiment, because the scientists decided to use the pictures of my sculpture UFO, the missing piece, to describe the different parts of the foreskin. In 2020, Foregen and Dottoressa Elena Bondioli partnership with the University of Camerino to test whether foreskin tissue samples will take hold on rats and sheep. So the 2 different experiments on rats and sheep are successful. We have just published the rat trial. Just to give you a summary of this trial, this study evaluated the biocompatibility of decellularized extracellular matrix derived from human foreskin for potential use in foreskin reconstruction. We used 26 rats, and 26 rats were implanted with the scaffold and divided into 2 groups, Group B and Group A. The first group, Group B, was 5-day follow-up, and the second group was 30-day follow-up. We did the examination of histologically and immunohistochemically for immune response, neovascularization, and recellularization. After 30 days, neovascularization and cell colonization were significantly higher compared to the 5-day group. Severe immune reaction, necrosis, or cavity formation was detected. So these results demonstrated the Foreskin-derived ECM scaffold elicited a limited immune response and promoted vascularization and cellular integration in vivo. These findings support its potential as a safe and effective biomaterial for foreskin reconstruction. Further research is needed to assess long-term integration and functionality before translation into clinical applications. So we have understood a lot of things from these two studies. We have collected a lot of data, and even if according the guideline, we were ready to undertake the first clinical trial in history that transplanted the real human foreskin on circumcised patients. We are very scrupulous and careful, and we always put the health of our patients first. If previous experiments guaranteed the complete success of foreskin decellularization, we had not yet done anything about matrix repopulation, so basically the recellularization. That's why we contacted Dr. Žiaran of the University of Bratislava, who had just published an excellent protocol for human foreskin decellularization, citing, among other things, the study conducted by Dr. Elena Bondioli, published by Foregen in 2018. Dr. Žiaran was enthusiastic about working with us, and we have come to this point. So this is the summary of the situation before to start to work with Dr. Žiaran. So I will give you the word, guys. Ryan.
Awesome. Thank you so much, Enzo, for laying down the historical context and reviewing with everyone how we got here. Right. So we also prepared a PowerPoint to kind of go through some of the recent research progress. And to just give you an overview, we are going to cover recent highlights, also show you our organizational chart so that you can see how the team is structured for managing the research that is taking place in Slovakia. And also we're going to review some of the personnel on our research team. And then we'll go over the progress with the research and where we are in terms of moving through the milestones. Yeah, okay, so first let's cover some recent highlights. First off, milestones 1 and 2 in our preclinical research project are fully completed, and we'll go into what that means in a little bit later. Also, a big highlight was, if you recall, over the summer, we did launch a $25,000 matching campaign in July that was successful. We are extremely grateful for your support and extremely happy to see the community rally in the way that it did. Everyone came together, and the community raised around $27,000, a little more than $27,000 that was matched. $25,000 was contributed for matching that. So in total, we raised $52,000 in a single month, which was fantastic. And then also, like Enzo was just going over, we also had some progress on the research that we had been conducting previously in Italy. So Dr. Angela Palumbo, the rat trials paper that her team wrote was accepted for publication. And it's going to be published in a journal called Bioengineering. So there's a link to that paper that was put out in the most recent newsletter. So if you would like to go and read that paper, you can go check out our website, go to the commentarium section, and pull up our most recent newsletter for that link. So yeah, next, just to orient everyone and share with you how the research team is structured in terms of how the research is being conducted in Slovakia and how it's being managed on our end. we thought it'd be useful to put together an organizational chart. At the top of this chart, we have Foregen. So that includes the board of directors, the whole team, includes Enzo, it includes myself, William, other members of the team, and the rest of the board members. So we oversee Beatrix and William, who are sort of managing the research on our behalf. And the people on the ground conducting the research include Dr. Stanislav Žiaran, Jan Kovac, and additional research partners that they have to work with. And so we'll go into that. But for example, they recently completed the biomechanical testing of the decellularized tissue samples. And if you've been following our newsletters, we share a lot of that progress in the newsletters. But Jan had to travel to a neighboring country and work with some researchers at a university in that country to use the equipment and facilities that they had to conduct this biomechanical testing. And it was an extremely complicated, time-consuming process. It involved like attaching these tissue samples to these machines that would apply torque tension to them, different amounts of torque tension, and they had to measure how the tissue reacted. And so it was very complicated. And and another example is recently they completed histology and immunohistochemical analyses of the decellularized tissue samples as well. And they had to work with other researchers at their university, at Comenius University, but in a different department. They're on the ground doing the work. We have Beatrix Zabeni Vargas. She is our clinical project manager, and she's sort of helping to oversee the whole process. And then William Musa, of course, who's on this call, is our chief science officer, and he's consulting at every step of the way and helping the team to make decisions on how to move forward. So just to review some of our team members, this is Beatrix. She's our clinical project manager. She does manage all clinical operational aspects from planning to completion. So she works very closely with the team in Slovakia and every step of the way. She coordinates with external partners, and she will be coordinating with a contract research organization in the future when we reach that point where we are ready to conduct the human clinical trials. She also develops clinical study documents for regulatory submission. So she's been working very closely with Jan Kovac at every step of the way. So Jan has been a superstar for us. He's been an MVP, and he's been managing a lot of these projects. So when it comes to decellularization, when it comes to the biomechanical testing, when it comes to configuring the bioreactor and so forth, he ends up producing a lot of data. So he sends us dozens and dozens and dozens of pages. He documents every detail of each protocol. He sends us all the slides of the histological studies and so forth. And Beatrix takes that data, and she's working with him to prepare that in a format that we can then submit to the regulatory authorities when it comes time to move to the next stage, human trials. So she's there to ensure that all activities adhere to strict GCP and regulatory standards. And basically what she does is she turns raw information into something useful and acceptable by the regulatory agencies. Then, of course, we have William, our chief science officer. William has been helping to set the overarching scientific vision and research strategy. He consults on all the R&D activities and experimental progress. So, for example, he has a good working relationship with Jan. And, when we went to go visit the team earlier this year, they did a lot of brainstorming on how to set up the bioreactor in the future and all kinds of things. William helps to ensure that scientific milestones are achieved on time and within scope, helps with Beatrix to coordinate the translation of lab research towards clinical application. Next, of course, we have Dr. Stanislav Žiaran. He is currently Foregen's chief medical officer. He's been providing essential clinical and surgical expertise as a urological surgeon, overseeing Jan's work, and is sort of the leader there of our project. He's a distinguished scientist leading the Comenius University research team, and he guides the medical strategy and oversees development of the surgical plan. And then, of course, Jan Kovac, our chief bioengineer. He's been leading the hands-on laboratory work for all the milestones, and he manages optimization of the decellularization and recellularization protocols. He will be operating and he is developing the bioreactor systems for tissue maturation. He's also very interested in 3D bioprinting and tissue engineering techniques, which may be useful as well later on. So just want to move quickly to an overview of our current progress. We gave a presentation earlier this year laying out the different milestones. And here's where we are today. So milestone 1 is the collection of donor tissue samples. That was started March 1st. All the samples that we need, which if I recall were 42 samples, have been harvested. But if we do need more samples in the future to finish this project, Dr. Žiaran can go and harvest more tissue samples. So milestone 2, that did begin on March 1st, and that was to implement and test the results of the decellularization protocols, and that was finished on June 2nd. Of course, just recently, if you've been reading the newsletters, all of the related testing was finished. The biomechanical testing and the histological and immunohistochemistry tests were completed. And then, so now for milestone 3, the initial phase of milestone 3 was completed. They did initial testing of the protocol. They did some recellularization work on some samples, and that was finished on August 1st. Now, the next and final phase of that milestone is set to begin soon and should take approximately 1 month to finish. Right now, Jan and William and Beatrix are working closely. They're going over the data produced so far to decide exactly which protocol to use to finish milestone 3, exactly which dynamic recellularization protocol to use. Once that protocol has been decided on, it should take approximately 1 month to go through and finish completely milestone 3. And then once that's finished, then the team will get together and decide exactly how to move forward with milestone 4, how to configure the bioreactor, and so forth. So we do have a little more detail on some of the activities that have been conducted in Slovakia. William, would you like to take over at this point and kind of share some of the more in-depth technical information about what they've been doing?
Sure, yeah. Hello, everyone. Thank you again for all your support and everything, spreading the word and joining this call with us. So in focus, we have the histo and immunohistochemistry, the biomechanical testing, and regulatory preparation, which honestly is the ongoing piece of this, which is consuming a lot of our time at the moment. So from milestones 1 and 2, and starting with 3, the information that was previously started on May 1st, each of these had immunohistochemical and traditional histology slides prepared as part of the analysis. So as part of each of those steps, each of those milestones, and there's going to be more of those coming out. We actually have an image of one of the folders just to show how many slides and how many images are being populated at each of these steps. And that's not all of them. That's it's just going to be a small snippet of what Jan is generating and what we have to parse through. And we use these slides to prove that, there's a complete decellularization, or when we recellularize, to show that there's recellularization with specific cell types. That would be in the immunohistochemistry side. And on the histo side, traditional histology, using that to show that we're capable of removing the cells and recellularizing with the new stem cells. The biomechanical testing was important because we want a regenerated foreskin that acts like the original foreskin, right? So understanding how elastic it is, understanding where the stress points are and some of the different elastomers is really important. So that was a big piece of the biomechanical testing that Jan and I forget the name of the other group that worked with him, but they worked together to perform these tests. And then regulatory preparation. So the regulatory preparation, all this information has to come together so that we can submit it to a regulatory agency for clinical research. And It sounds silly sometimes, but all of that started with milestone 1, that everything had to be done in a specific manner with specific documentation, so that when it comes to starting human clinical trial, we can get the approval and we can go ahead and start. So this is just an example of some of the decellularized tissue. This is from when we visited the research facility earlier this year. And this is an image of one of our folders. This is just a quick screenshot. We were actually going through this the other day. Ryan and I were going through a folder with data from Milestone 2. So this screenshot probably doesn't look very meaningful, but these are all immunohisto and histology images of various tissues. We've kind of stripped away the information so that it doesn't give you any information as far as like patient information goes in accordance with HIPAA. This is the histology and histochemical analysis from the completed, I think this is all from Milestone 2, if I recall, when we took the screenshot. But the some of the analysis was showing DNA containing cells that were, there's no DNA left. When you do immunohisto staining for that, it was showing that it was clear, and the results were good. The results were very good, which we already knew they were supposed to be. So this gets us into starting with Milestone 3. So again, parts of Milestone 3 were run in parallel with Milestone 1, but the parts that still need to be completed, dynamic recellularization, and that's going to be Jan working on optimizing the recellularization process and the protocols. So that's actually where we're at now, is actually reviewing some of the protocols that look promising to use. So I think a big piece that a lot of people in this industry, or peripheral to this industry, don't understand when we talk about Foregen, when we talk about what we're doing in our mission statement, is that no one's done this before with this specific tissue. There's a lot of protocols out there for dermal. There's a lot of protocols out there for specific organ tissues in controlled environments, but there's nothing for what we're doing. So we're taking several different protocols, putting them together and working with that information to see what works, and then modifying from there. So we have to identify growth factors, visualization methods, and we have to do detailed tissue analysis, like you saw from this that file of just a screenshot. And that's not even the entire file of how many slides get produced when we do detailed tissue analysis. And then the outcomes will be validated protocol. So once we complete that, figure out what protocol works the best. So the protocol is like, think of it like the recipe, right? When you're cooking. So that's like the recipe for how to make your target, which in this case is the recellularized foreskin. And then we have to characterize the recellularized tissue, so more histology to show that it matches the native type. So comparing it to a cadaver's tissue or the natural tissue. And then in the image here, this is from, again, when we visited, and this is an image of the benchtop, one of the benchtops, which is part of the recellularization bioreactor. So getting into Milestone 3, big piece of that is that the bioreactor setup that Jan is using is very experimental and very modular, which is great for flexibility and being able to pivot and try new things. But it's very time consuming and very labor intensive for Jan and anyone working with him. So this is more a closer up image of one of the bioreactor vessels, and it's all pretty much custom made. So they've taken parts from other bioreactors from like the fermentation industry that they've come up with very novel ways to use. It works. It definitely works. But as you can see from this picture, it's complex, it's time intensive, and it was a proof of concept. Can we do this? Yes, we can. Can we make it better? Can we automate it? Oh, it's another picture of his. So these are some of the control pumps, peri pumps. This is where the bioreactor really shines with us. It optimizes the tissue prior to implanting. Think about like previous conversations we've had with surgical methods and previous conversations Foregen has had with traditional surgeons. There were multiple surgical steps, really long incubation times inside the human body. And having a competent bioreactor method will help alleviate a lot of that and make it a more streamlined, simplified process. And the final tissue, so at the end of the bioreactor research steps, we have conduct a final tissue analysis. This will help with our protocols for implant, and then we'll have to make sure that the tissue is characterized prior to that. So this goes into, we showed you the bioreactor setup, why it's important. One of the things that came up was Dr. Žiaran's team just got a grant independently to work on their bioreactor development, which is going to be huge for us. We're going to be working in conjunction with them, and this may be a possibility for us to work on a bioreactor that can be automated and really alleviate some of Jan's time. I think we sent an article out highlighting Jan and how much time he spent. He had some like 10-hour days, multiple days a week. And I really love his dedication. He's a really great guy. He's really smart. And if we can do something to alleviate his time on something that's kind of like a labor-intensive menial process, I'd rather have him, analyzing data and coming up with new experimental procedures than pressing a button because he needed to stand there and time something and press the button. So if we can automate a lot of that, and him and I have talked about that when I was visiting, is automating this process and coming up with a bioreactor can, take up like a smaller piece of the benchtop, because that's another from the images that you guys saw, the benchtop is another piece of it. Like, they don't have room for more experiments in their clean room because 90% of their benchtop is taken up by the bioreactor. So the ideal situation from your perspective, from like a end user, right, from an end patient, is what would be ideal is, a room where they have 6 or 7 bioreactors and 2 or 3 bioreactors doing decellularization and, 3 or 4 bioreactors doing recellularization. So the idea here is, how can we maximize the effect of what we're doing? How can we maximize for the end goal once clinical trials are done? And that's a big piece of this too, is we can make sure these bioreactors are, working to make this process more streamlined and faster. To call it a farm, but kind of, having multiple pieces of equipment working to try to make as many usable foreskins as possible for patients. So this gets into the next steps. Ryan, did you want to go through this? This is kind of like the rest of the roadmap you were talking about.
Yeah, sure. Thank you, William, for explaining those, getting into depth on that. And I think these next slides are just to kind of go over the next steps. So I'm sure, everyone's very curious about where we're going and when we're going to get there. We don't have hard timelines right now, but for the next steps, we have to focus on, as we were mentioning before, finishing milestone 3. So once we do select the dynamic recellularization protocol that we're going to go with, it should take about 1 month to test that, to get through that completely and finish milestone 3. Then once milestone 3 is finished, all the data will be considered and assimilated and gone through, and then Dr. Žiaran will propose the method that they would like to go with for going through milestone 4. So that's something that the whole team will have to sit down on and come to an agreement on how to proceed with milestone 4. And again, that's Dr. Žiaran and Jan and Beatrix and William kind of driving that conversation. While this is all happening, Beatrix will continue to work with the team in Slovakia on preparing the final report and preparing the application for ethics approval. She's the expert on that. She has a lot of experience in understanding the regulations. So there's all this data has to be put together in the right format and in the right way, and we have to make sure we have all the data we need. So one example of that recently is, William had mentioned that Jan was putting in 10-hour days. Like he was doing that, for example, when he was working with the partner university in Austria on the biomechanical testing, and Beatrix had to do some research to work with Jan to figure out exactly how many tissue samples we had to put through the biomechanical testing, because it is time consuming and it does cost money, but you also need to hit a certain number of tissue samples. Otherwise, the regulators will say that you didn't test enough. And then when it comes time to apply for approval to do human trials, we don't want to hear like, oh, we didn't test enough decellularized tissue samples, because then we'd have to go back and decellularize some more and then put them through biomechanical testing. So that would cause delays down the line. So Beatrix and Jan got together and figured out what the right number was. And then they went ahead and pursued that number. Right. And then, so for milestone 4, the team will design and prepare the bioreactor. Now, that's sort of part one of the next steps. Part two, as we've gone over before, once all these milestones are finished with the preclinical research project, then Dr. Žiaran puts together a surgical plan. Beatrix and others identify a CRO that we can work with, and we work that out. And then together, they create the study design for the human clinical trials, and we go ahead and apply for the ethics approval. Now, a lot of those things can be done in parallel. It shouldn't be too time consuming. Next steps, part three, is just kind of other activities, other optional activities we can engage in. So as you know, as we shared in the Discord, last summer, we had a call with a distinguished researcher in Europe who is a chemist working with hydrogel technology on bioprinting. And we decided to pursue a grant opportunity together with the Novo Nordisk Foundation. Now, the intention behind that application was to pursue a secondary and optional bioprinting project. The idea there was to get ahead of the curve, and a few years down the line, if that project was successful, that could help alleviate potential tissue sourcing challenges, tissue supply challenges in the future when it comes time for clinical application. Unfortunately, our attempt to win that grant was not successful. However, we have a good relationship with this bioprinting researcher, and we will continue to look for other opportunities. Again, those are just things that we're also doing in addition to this main research track. So we are very busy behind the scenes. I know sometimes it does look quiet, but we are all working together. Enzo's been doing a lot of work identifying other private foundations that we might try to fundraise through, and so on. So, if you guys out there, if you want to volunteer and help us look for funding opportunities and even apply for funds, we welcome that. So you can always send us a DM or send us an email. So that's just to kind of give you a picture of other things that we're working on at this time. Right. So that's it for the PowerPoint. Hope you guys all found that informative. Thank you, Enzo and William. So now at this point, we can go ahead and move to the questions and answers section. So we'll now give the floor to you. Go ahead and raise your hand in the audience there, and we'll select people to come on up and ask a question.
Disclaimer. For privacy reasons, the original voices in this Q&A section have been replaced with a generic synthesized voice. The frenulum is rarely mentioned in your videos, but it matters deeply to many of us. Once the scaffold is applied to the penis, do you anticipate any complications involving the frenulum or the surgery as a whole? And looking ahead, what timeline do you see for completing the surgical part of this work? Are you pushing quickly toward human trials, or taking a steady, careful approach to make sure that first attempt is truly right?
To answer the question about there's no cutting corners when it comes to, there's regulatory agencies in Europe that we have to go through, and they're like, hey, you need this, this, and this, and this. So we can't really skip any of those steps. We're trying to go as fast as we can by meeting all those checkboxes, if that makes sense. So there are instances where something is successful and we're going to move forward with it to the next step, right? We're not going to stay there and just try 10 different things to have 5 different options. If we can get to an option or we can get to a result that meets our criteria, we're going to go with that. To answer the other question about the frenulum and the surgical plan, that was a question that we raised with Dr. Žiaran. And again, he's the urological surgeon that's in charge of that. And he is actively thinking about and putting together a surgical method. And based on how he's removing the foreskin from the cadavers, he's using that to formulate how he's going to create the surgical plan to reattach. Now, part of that is contingent on how well we can recellularize and what that final product looks like from the bioreactor. To answer that question, once milestone 3 is completed, Dr. Žiaran can use that information, that final piece, to put together a better idea of how he's going to create a surgical plan. And then from there, work with a CRO, a contract research organization. So it's not really a direct answer to your question. I apologize about that. But the answer is we're working on that. That's definitely the frenulum specifically was brought up. He brought up as well. We know that's a piece of it. We know that that's a piece we have to work on, but we're not there at the final surgical plan yet. We're still at the recellularization point. We're still at the bioreactor recellularization point. We have to get through those.
I'm wondering, is there any way to run parallel experiments specifically to recellularize the frenulum? Or is that something that has to wait until other steps are complete?
That's going to be part of the recellularization in parallel. If they can get cadaver, when they use the cadaver samples, I believe they do have frenulum attached on that. So they can analyze that and try to recellularize that.
I just wanted to add that they do include the frenulum in those tissue samples. So the frenulum is moving through the decellularization and recellularization protocols.
Yeah.
In the videos you've shared, what exactly are we seeing being recellularized? Is that close to the final product, or is it still an early developmental stage?
Oh, in the video, so you're talking about the YouTube videos that show Jan. Those are complete samples that have been fully decellularized.
Just to make sure I understand, there hasn't been any recellularization yet, right? The samples in the videos look processed, so I wanted to confirm.
They started an initial round of recellularization. They recellularized like part of the tissue samples to test certain parts of the protocol, and those tests went well. Now we're at the stage where it's time to select the recellularization protocol that's going to be used on the entire foreskin, and it's a dynamic recellularization protocol. So they're going to pump fluid all around the tissue and make sure that the fluid comes into contact with every cell, and so it's a whole complicated thing, but that's what they're getting ready to do next.
To add to that, there were a couple different recellularization methods. So like the bioreactor, there was a traditional recellularization method in like a cell flask. It's like a petri dish that's closed if you haven't seen one before. So they were experimenting with different recellularization methods, and I do believe there were some whole or larger piece of the foreskin that were recellularized, but I don't think we shared images of those yet because it was one or two, and it was just a stepping stone to say like, okay, we can move on to the bioreactor. There were bioreactor recellularization of larger pieces, but they were used for histology.
Every man's body carries its own history. Some men have scarring or damage near the sulcus or the frenulum area because of their circumcision. In those cases, you'd need to restore not just the foreskin, but also the inner tissue that was affected. When you remove and decellularize tissue samples, does that process reach all the way to the sulcus, or only over the typical amount of tissue?
So when they're doing the cadaver tissue, they can remove quite a bit. So I think to answer the question of if someone suffers from that, would there be a possibility of adding enough tissue? Absolutely. How that would work surgically is a question for the surgeon and for how he creates that surgical plan. But you'd have to remember that each person isn't, like you said, each person is an individual with an individual need based on what was done to them. So that would all come to light during the consultation with the surgeon at that point. Say like, hey, this is my situation, and they would have to kind of use that surgical plan to formulate a method or treatment plan for you as an individual. So it's, yes, the surgical plan is a standardized set of, it's going to be this, and this. That's going to change, or that's going to be elaborated more from person to person. But to answer the question about how much is removed from the cadaver, in the videos or the images, it was easy to see, but some of the cadaver tissues, quite substantial. Like he removed a lot of tissue. Remember that the team we're working with, when Enzo started communication and found them, they were very experienced with recellularizing urethra, and that's actually a big piece of their personal research and personal interest is urethral regeneration. So our goals really match up. That's a very difficult piece of a very integral piece of male anatomy that you need for full functionality. So a lot of their experience went hand in hand with our needs. So there's times where he pulls like all the tissue off the penis because he's removing the cadaver penis for urethral samples. So yeah, we get a lot of tissue from some of those.
As you scale up for human trials, with several bioreactors running at once, would you extract as much tissue as possible and later shape it for each patient? Or would each extraction be customized from the very beginning based on the patient's needs?
What I imagine is kind of what we're doing now, which is extract as much as possible because it's cadaver donated, and we can use that for either other research. If we it's not like wasted, right? If you trim some down, or if we say like, oh, we only need a small amount, there might be a smaller piece of tissue somewhere else, or we could use those. Remember, when it's decellularized, we can use that for other applications as well. If Dr. Žiaran's team is trying to regrow a piece of urethral tissue, in the past, that the best option for treating someone with urethral damage was actually using their own foreskin to do that. So none of it would go to waste, if that's the crux of the question. But I believe it would be, for streamlining it, it would be as much tissue every time, and then as needed. And again, like you mentioned, there's going to be people that have extreme damage done, and having more tissue available to help treat them, I think, is always a better option.
I read that in one experiment, pigmentation from a donor wasn't completely removed. But would that really matter in the end? Since the tissue is decellularized, wouldn't the patient's own cells recolonize it and gradually restore their natural pigmentation?
Yeah, you are correct. Your cells would take over and eventually repigment, and it's also dependent on how much light exposure. But another piece of that is, I believe, all the images that, from what I've seen, it's usually called ghost tissue after it's decellularized. Sorry, after decellularization, it's called ghost tissue, and I think I see what you're referring to, the comment. And it usually looks like fairly translucent and like pale, like white, hence the ghost tissue terminology. Once it's recellularized, it typically stays pale for quite a bit. And part of the bioreactor experimentation in the modular bioreactor setup, they were actually exposing with UV light for a few reasons. It's actually an important cellular function. You need some light to stimulate the cells. And in the final steps of the bioreactor, obviously getting into milestone 3, experimenting to see if that changes pigmentation. But like you said, in the end, once you've undergone the attachment and once the surgical procedure, your cells in your body are going to start repigmenting. So I'm not sure what that timeline would look like, but your body would start to repigment.
Yeah, and just to add to that, when Enzo and I were in Italy, we saw some of the tissues, some of the decellularized tissue samples that were used in the sheep trials. Those tissues were prepared using a different decellularization method. And as William was saying, if you look at some of the pictures of the decellularized tissue that's been prepared in Slovakia, it does look like ghost tissue. It does look like there's no pigmentation. The samples we saw in Italy, there was pigmentation, but again, that was a different decellularization method. So, yeah.
A lot of circumcised men carry small irregularities on the glands, little bumps or uneven spots that weren't meant to be there. Does Foregen have any sense of whether those could be corrected, or might restoring the foreskin allow the glands to naturally heal and improve over time?
That would be a question. That would be a question during the consultation with the surgeon. Every person is different, so there might be situations where there's a surgical procedure or I don't want to say cookie cutter, but like a standardized surgical procedure. I just don't know the answer for that, especially for when you consider how many people and how many different types of conditions there will be. So the end answer would be you have to bring that up and be very specific and very direct with your consulting surgeon.
Is there any realistic estimate for when human clinical trials might begin? I know the path of scientific research can shift, but even a general sense would mean a lot to people following this closely.
Well, this doesn't depend on us. We're doing a great job. Sorry, Ryan. There are a lot of delays due to regulations, to bureaucracy, and we are doing what we are supposed to do. So we are doing everything perfectly.
Yeah, and to add on to that, what Enzo was saying, I think it's best to focus on what we've accomplished and what the next steps are. and just see that we're tackling each step along the way, and something to be happy about, something to be grateful for is that we have not run into any major roadblocks or hiccups or had to go back and redo anything. So we have been making steady progress, and there have not been any major issues so far. So I think we just have to kind of keep our feet on the ground and look at each tangible step moving forward.
Well, of course, we are focusing our regeneration process on the foreskin that is full of at least 70-80% of the nerve endings. So we think that once we regrow those nerve endings, they can send the signals to the glands. And this also answer to the questions raised by Stephen. In some way, the glands, the pleasure of the glands, the sensitivity of the glands depends on the foreskin. So once we regrow the foreskin, and after that it's regrown, it's going to take some months to regrow the nerve endings because it's a slow process of nerve reinnervation. I am confident that even the glands will benefit.
Would anyone on the Foregen team ever be able or willing to participate in the human trials, or is that not possible because of safety concerns or regulations?
Yeah, there's always a risk with any human trial, but to answer your question, so would any of us do it? We've had this conversation internally with our clinical project manager, Beatrix, and basically there are a lot of regulations around this and very high standards, especially around things like conflicts of interest or jeopardizing the results of a trial. So, like, one of us couldn't really participate because there wouldn't be a lot of trust in our in the reporting of our patient satisfaction because we would be very biased. So you want to recruit people who are kind of just from the general population. So and for practical and logistical reasons, you want to recruit locally first. So if, for example, the human trials were conducted in Slovakia, you'd want to recruit locally in and around Slovakia just because of the logistics of having the patient travel to the clinic and return to the clinic for follow-up visits and so forth. Is there anyone else want to ask a question? All right. Well, if there are no further questions, we could wrap this up. Oh, it looks like we have someone on the stage.
I donate regularly to Foregen, and I know many others do too. If the project suddenly received a significant contribution, maybe $20, $30, or even $50,000, would that actually speed up the road to human trials? Or would things move at about the same pace? What specific steps could truly accelerate with more funding?
That is a great question.
Yeah, really, it is.
From the regulatory stuff, that's going to go at the speed it's going, but from like the bioreactor standpoint and from like other ancillary pieces, I do think there is a relationship there with how much we could throw at that to make it go faster. I don't know those answers at the top of my head. That's really a question for the entire board. And we have to like bring that up during a board meeting to say, hey, where are our bottlenecks and choke points, and would additional funding at those points help make those go faster? I do think there are a few places where that could help and make things go a little bit faster. Honestly, that's something that Ryan, we could make an action item for us to take a look at that and then come up with like solid answers for what exact points and what values would be needed. Unless you know off the top of your head.
No,
which I doubt.
I agree. Off the top, that's so hard to answer because, like you were saying before, when you do this research, there's no cutting corners or anything. And you have to be very thorough, and you have to meet the requirements of the regulators and so forth. So in terms of speeding it up, I don't know. But what comes to mind is if we did have a larger budget to work with, I think it might expand the options in terms of what caliber like CROs we could approach when it comes time to get really serious about planning for the human trials and so forth. So I don't know. And I think that's also something like our team in Slovakia might be able to weigh in on with us as well. So like you said, William, we'll have to discuss that and make that an action item to talk about.
Yeah. Yeah, but thank you for that question. That was a really good question. And we will today's Sunday. We'll bring that up this week in the board meeting, and the research report meeting that we do. And we will or Ryan can post that, or maybe in this group on the Discord post that.
As a programmer, I'd be glad to help with the website. I also believe that if Foregen clearly showed how donations are allocated, how much each research step costs, and what each goal supports, many more people would feel motivated to donate. Is that kind of transparent breakdown something you've considered?
Yeah, thank you for your suggestions and your commitment as well.
Yeah, it's a really, really good idea. I think that is something that we can definitely do is put some like help wanted. Like if we have a specific, we need a specific volunteer or if we need something specific. And then also, like you said, for the for each of the goal or goal markers, like, hey, this goal marker for the bioreactor, if we could get this much raised for this, we could accomplish this faster. We'll definitely have discussions about that this week. Thank you.
Okay, final call. Anyone else want to hop on stage and ask one more question?
Have you considered creating short-form videos on Instagram, YouTube Shorts, or TikTok? Content like that spreads quickly and could bring a lot more attention, support, and hope to Foregen.
Yeah, thanks, Eli. That's a great question. We've had volunteers in the past too help us with making social media content, and so if there's anyone out there who wants to volunteer to help us in that way, like please reach out. That is something we've talked about doing, and we just have to kind of just dedicate ourselves to do it and get it done. So
I think it's a good question. I think these platforms have the capacity to reach faster young generation. I personally, I come from another generation, so I don't even have Instagram and TikTok, but I think it's a great idea. Thank you. So thank you guys for all your support and your continued donations.
Yeah, we super appreciative of your support, and thank you for taking the time to join us today as well.